My partner and I both love pizza. So when we get one, we make sure it is equitable. We split the pizza evenly between the two of us. It reminds me of assigning formal charge to atoms and molecules. When two atoms come together to make a chemical bond, they are sharing electrons. When we assign formal charge, we assume the atoms are sharing the electrons evenly. Each atom gets half of the shared electrons, just like pizza. This is real chem. Chemists assign charges to atoms in a number of different ways. Depends on what they're interested in at the time. Formal charge is used to decide the best way to represent the molecule with a Lewis structure. The best structure, it's the one that minimizes the formal charges. Often, there is only one Lewis structure that satisfies the octet rule, while other times, especially when there are atoms that can expand their octet, we can find more than one structure that satisfies the octet rule. This is when formal charge comes to our rescue. Let's explore. Let's use the example of this phosphate ion. This ion is all through our bodies, so it's like super important in biochemistry. Here are two candidate Lewis structures. Both obey the octet rule, but one uses an expanded octet for phosphorus and the other doesn't. We can decide which is better by using formal charge. In assigning formal charge to an atom, we start with the number of valence electrons the atom would have as an isolated atom. We then subtract the number of electrons the atom has assigned to it in the Lewis structure. If these are equal, formal charge is 0. The atom has neither lost nor gained electrons by joining with the other atoms to make this molecule. Otherwise, it develops a formal charge. In assigning electrons, an atom gets all of the electrons that are in its lone pairs, because those electrons reside solely on that atom. But the atom only gets half of the bonding electrons, because we treat these as being shared equally with the other atom participating in that bond. Let's first consider the oxygen atoms that make a single bond with the phosphorus. Oxygen has 6 valence electrons as a free atom, so in calculating formal charge, we start with this 6. We then subtract 6 for the 6 electrons in lone pairs, and subtract 1 for its share of the 2 electrons in the single bond. This gives a formal charge of -1. This negative charge results because the oxygen atom has 1 more electron in the molecule than it does as a free atom. A similar process reveals that the oxygen atom that makes a double bond with the phosphorus has a formal charge of 0. Converting one of the lone pairs to a bonding pair reduced the number of electrons assigned to the oxygen by 1. We can use a similar approach to phosphorus. We start with the 5 valence electrons of free phosphorus. When surrounded by 4 bonding pairs, or 8 bonding electrons, it is assigned 4 electrons, giving it a formal charge of +1. When surrounded by 5 bonding pairs, the formal charge is 0. We can check our work by making sure the formal charge is summed to -3, the overall charge of this ion. Now that we have the formal charges, we can decide which of our 2 Lewis structures is best. The structure with the double bond is better because it minimizes the formal charges. It assigns a 0 formal charge to 2 of the atoms. The other structure assigns a non-zero formal charge to all of the atoms. Using formal charge to determine the bonding pattern in a molecule is all about figuring out how to best share the available electrons among the atoms. It's sort of like sharing pizza among friends. We try to make sure everybody gets the amount of pizza they want, but if we have to give one person more pizza than the others, we give it to the person who's most hungry. So, explore, and remember to have fun.